Hello there, welcome to my channel once again. This is Electro Teach channel, the channel where we teach knowledge of electronics, computer, instrumentation, and mathematics. Today, we are still talking about the DC circuits. We are furthering our discussions on DC circuits in electrical electronics. So, I want you to pay attention to the knowledge we are going to share also today. We're going to look at the current divider formula. In the past, we have discussed series and parallel circuits. We have discussed series parallel circuits. We have discussed equivalent resistances of series circuits, equivalent resistance of parallel circuits. Also, we have discussed main differences between AC and DC circuits. Today, we want to go into the current divider method. Now, if you are new on this channel, this is Electro Teach channel where we bring information of electrical electronics, computer, instrumentation, and mathematics. Subscribe to the channel so that when I bring new videos like this, you get notified by YouTube. And if you are a returning subscriber, thank you once again for coming to see my videos. Now, we discuss series equivalent resistance of series circuits, equivalent resistance of parallel circuits. You can check the channel and the description box. You see a link that gives you information about that. Click the link and watch the videos on that. Also, series parallel combination. There's another link in the description that you can click to watch that one. But today we want to learn basically current divider method. Now, when we have a series parallel combination of resistances in a circuit, there will be division of voltages and currents from point to point. So we want to know how to determine the voltages at a point and then how to determine currents in branches of a circuit. And that is why we need to learn voltage divider method and current divider method. These are very applicable in determining fraction of voltages or currents in a particular section or segment of a circuit. So we are going to use an example to demonstrate this. We have current divider method. Okay, and then voltage divider method. Those are the two parts we are learning. Voltage divider method. All right, so we have a circuit that we're going to use an example. We have a simple circuit in this way. We have 9 volts connected. So we have 5 ohms here, we have 3 ohms, we have 5 ohms here, and we have 2 ohms here. Now, part of our job here is to determine the total current supplied by the potential source to the entire circuit. Then, we want to also determine the voltage on each of these resistances. This, and this. So, to begin, let us label the resistances. Let us give them number. So, let's call this one resistor R1. This is resistor R2. This is R3. This is R4. This is what you need to do when you are given a circuit to work with. You must identify the resistances by a simple notation like this. R1, R2, R3, and so on. All right. Now, the first thing to do is to determine the total equivalent resistance in the entire network. And to start, you usually start from the right-hand side of a network like this. You cannot begin from here, because if you begin from here, you may not be able to determine the relationship between these parts of the circuit and these other parts of the circuit. But to simplify the circuit, you start from your right-hand side and then you begin to minimize it, reduce the combination of resistances towards the left hand side until you get the total equivalent resistance. All right. So we can see that resistor R3 and R4, they are in parallel. So we need an equivalent of that, equivalent of resistor R3 and R4. Now we can call the equivalent of R3 and R4, we can call it resist. We can give a notation to that as resistor RA. So RA equals R3 parallel to R4. Now, if you do that, we can redraw the circuit in this manner. This is 9 volts. Here we have resistor RA, and here we have resistor R2, and here is resistor R1. So resistor RA can be calculated this way. RA equals R3 multiplied by R4 divided by R3 plus R4. All right, and R3 is 5 ohms, R4 is 2 ohms. That is 5 times 2 divided by 5 plus 2. This is 10 divided by 7. 10 divided by 7 is the value is 1.43 ohms. RA equals 1.43 ohms. Now we can now see that resistor R2, RA, and R1, they are all in series. After simplifying this particular segment of the network, we see that R1, R2, and RA, they are now all in series, such that we can redraw the circuit this way. And this is our 9 volt supply, and this is R total. This is R total, and the R total is given as R1 plus R2 plus RA, and that is 5 ohms plus 3 ohms plus 3 plus 1.43. That is 9.43 ohms. Now we can determine the total current coming out of this current I coming out of the circuits of the power supply as V divided by R total, and that is 9 divided by 9.43, and that gives us 0.95 amp, 0.95 ampere, and that is total current in the circuit that is coming out of the power supply unit here. Now, the potential source is sending out current of 4.95 ampere. That same current passes through the resistor R1, resistor R2. But then, when it gets to this node or this junction, the current divides into 2. So we can have 2 currents here, I1, I2. So we can now determine the current in each of these branches by using current divider method. All right, can use current divider method. Okay, so we need to redraw the circuit once again to actually get what we are looking for. Now, when the current gets to this point, it divides into 2. So we can use current divider method to divide it between 5 ohms and 2 ohms to get current I1 and I2. Now, let us determine that quickly. We can leave it this way and then go ahead and use the current divider method will be used now to determine the current in these 2 branches. I1 using the current divider method equals I multiplied by R4 then divided by summation of R3 and R4. And that gives us 0.95 multiplied by 2 ohms divided by 5 plus 2. That is 0.95 divided times 2 divided by 7. And then if you punch that on your calculator, this is 0.273 amp. Now, to determine the current that is flowing in R4, which is I2, you can still apply the same formula, or you can subtract this value of current from the total current. But since we are learning current divider method and voltage divider method, we need to use the current divider formula to explain or exemplify how it works. I2 equals I multiplied by R3 over R3 plus R4. That is 0.95 multiplied by 5 over 5 plus 2. And the answer is 0.679 ampere. That's the answer. 0.679 ampere. All right. So we determine the current in those two branches.